Hi everyone, welcome back. In this video we'll talk about abstraction in Java and we'll begin with a real-world story to help you picture it. Let's start with something simple. Think of a car dashboard. When you sit in the driver's seat, what do you see? A steering wheel, pedals, buttons and a gear stick. You press the accelerator, the car moves. You turn the steering, the car turns. But do you ever see how the engine actually works? Do you understand how fuel gets injected, how the pistons move, or how the crankshaft turns? Nope, you don't need to. All that complexity is hidden from you, and that's the beauty of it. What you do get is a simple interface to drive the car. That's abstraction in real life. Only the necessary parts are shown to you. The rest, the complicated machinery, is hidden. Now let's bring this idea into Java. In Java, abstraction means hiding the internal implementation details and only showing the features that are relevant for the user. You define what an object does, not how it does it. You focus on the functionality, not the internal logic behind it. So how do we achieve abstraction in Java? There are two main ways. One using abstract classes and two using interfaces. We'll start with an abstract class. Let's say we are building a system for payments. We have a common structure, whether it's a credit card, a debit card, or UPI. So we create an abstract class called payment. Inside this class, we define an abstract method named makePayment. This method doesn't have a body. It's just a declaration. Why? Because we want each payment type, like credit card or UPI, to provide their own version of how the payment is done. We are only defining what should happen, not how. Now let's build this out fully. We create two subclasses, one called credit card payment and another called UPI payment. Both classes extend the abstract class payment, and they provide their own implementation of the make payment method. In credit card payment, we might simulate entering card details and processing through a gateway. In UPI payment, we might simulate entering a UPI ID and confirming with an OTP. So the calling code just needs to say, hey, make a payment. It doesn't care how that payment happens behind the scenes. This is the power of abstraction. Imagine later you add PayPal or wallet support. You just create another class that extends payment and defines its own makePayment method. The calling code doesn't change at all. That's abstraction in action. It hides the complex logic and only exposes what's needed. Just like you don't need to know how a car engine works to drive it, you don't need to know how a payment is processed internally to trigger it in code. That's why abstraction is so important in Java and in real-world development. It simplifies how we think about systems. It lets us work with interfaces rather than implementations, and it makes code easier to manage, scale, and update. So we were talking about abstract classes. Now let's take the idea a step further and understand abstraction using interfaces. Let's say we have an interface called vehicle. This interface defines what a vehicle should be able to do, like start, stop, and accelerate. But here's the key. It doesn't say how these things are done. So now, if a class like car implements the vehicle interface, it must provide the actual implementation of those methods. Same goes for a bike or a bus. Each vehicle knows how to start and stop, but they all do it differently. So the interface simply sets the rules. It defines the what, not the how. This gives you the freedom to change the internal logic of each class without changing the interface. You are separating the idea from the implementation. That's the beauty of abstraction. Now let's quickly understand why abstraction is so useful. The first benefit is simplicity. Abstraction lets you work with high-level ideas instead of getting lost in details. When you use an interface like vehicle, you don't care how each class handles acceleration, you just call accelerate, and it works. The second benefit is flexibility. You can switch out implementations easily, maybe replace a car with an electric car without affecting the rest of your program. The third is security and control. Abstraction hides unnecessary details, which reduces the risk of misuse and keeps your design clean and intentional. Now let's address a very common confusion. What's the difference between encapsulation and abstraction? Encapsulation is about protecting data. You put your variables inside a class, make them private, and give access only through public methods like getters and setters. It's like locking your valuables in a safe and giving people keys, but only for certain drawers. Abstraction, on the other hand, is about hiding complexity. You define what should be done, but hide how it's done. Think of it like the buttons on a washing machine. You press start and the machine takes care of the rest. You don't see the wiring or the water levels, just the result. So in short, encapsulation protects the data and abstraction hides the logic. They often work together, but they solve different problems. Let's wrap this up with a quick recap. Abstraction is the idea of showing only the essential features and hiding the details. We use it in Java with abstract classes and interfaces. It helps us design flexible, secure, and scalable systems. It separates the what from the how, just like a car separates the steering from the engine logic, and it makes your code easier to maintain and extend in the long run. Thanks for watching, and I will see you in the next Java lesson.